So we're going to do a little titration today. And whenever we're going to titrate, the first thing we have to do is make sure that our pH probe is calibrated. So our pH probe, it comes in this little jar with a solution to keep the sensor stable. I'm going to rinse this off a little bit. To calibrate, I have standard solutions of pH 4 and pH 10. And I'm going to put that in the computer and tell it this is pH 4 and then make a reading, and say this is pH 10 and then make a reading. And that gives it 2 data points so it can accurately measure the pH of any sample that I give it. So I'm going to type in 4.0 on my computer. Then rinse it again. I'm going to give it the standard of pH 10. Put that in. It is 10, right? So I'm all set up here. Let's take a look at what I've got. Down here, we've got some acetic acid. I put about 20 mils of 0.1 molar acetic acid in there, and then I added some water just to make sure it was high enough to cover the probe and to allow the stir bar to work properly without splashing all over the place. My pipette is filled with sodium hydroxide, again, about 0.1 molar sodium hydroxide. The concentrations, the amounts, they don't matter so much for this particular experiment. What I need to know is the relative amounts. So as I add the sodium hydroxide, I'm going to make a buffer solution. I'm going to produce more acetate ions, and I'm going to reduce the number of acetic acid. So if you remember our David Hasselhoff equation, pH equals pKa plus the log of the concentration of the conjugate base over the concentration of the acid. I want to get that log of the conjugate base over the acid. I want to get that to 0. I'm going to go past that to find the equivalence point, and then half of the volume that I've added, at that point, that's the place where my pKa is equal to the pH. So I'll just see what the pH was there. So I'm going to start by taking some readings. When I go to collect the data, what I have to type in, I have to type in the volume that I've added and then make a reading, and it's going to tell me the pH. So right now I've added 0, and I'm going to go ahead and take my first reading. So I've got a pH of 2.48 for our first reading. And I'm going to go ahead and add about a mil. .00, right? Because I have hash marks that give me the tenths, and so I can estimate the hundredths place. So 1.00 is my volume. So my pH has gone up a bit, and it's not surprising. When we're titrating a weak acid with a strong base, right, we're going to have that part where it goes up, but then it's going to start to flatten out as it buffers, and so we should see that. So that pH was about 2.8. I'm going to add another mil. Having a stir plate is nice. It cuts down on the amount of time it takes for the solutions to diffuse together and react. So by the time I put in a mil, go over and type in a reading, by the time I hit collect, that reaction is pretty much done. So I'm going to add another mil. So this is a lot of just add a little bit, type in how much you added, add a little bit, type in how much you added. We kind of do that over and over again. It's taking a while, and that's all right. Our graph is steadily climbing, starting to flatten out a little bit, it looks like. So at this point, I can see the graph is really starting to hook upward. And so I'm going to slow down a little bit and try and get a real fine point on that equivalence point. Just add a little bit at a time. So I'm adding a little less than half a mil each time now to try and get a fine point on this. The pH has jumped up to almost 11, so it's way up there now. And it's starting to flatten out again. So I've collected all the data from that one, and I'll take it home and I'll show you how to do the data analysis on it. So I'll do the first one, show you how we're going to calculate these things. So the second titration that we're about to do with the unknown acid, you will do all the calculations on that one. Hey guys, back home, going to start looking at some of these data. So this is that graph. Let's look at that with a little more space. And I want to see exactly where the equivalence point is. I want to see where that place is where we used up all the acetic acid and neutralize it all with the sodium hydroxide so that I can find half of that. And remember, half of that is going to be where the concentration of the conjugate base and the acid are equal to each other. And at that point, I take the log of the conjugate base over the acid, those concentrations. I'm going to find that that's zero, right? The log of that is going to be zero because the log of 1 is 0. So that means that the pH is going to be equal to the pK. And so I can find pKa, and therefore I can find Ka. So to be clear about where this little point happens, this little inflection happens, where we flip there, I want to take the derivative of this graph. And actually what I really want is the second derivative, but I may as well look at the first derivative as well. So I'm going to look at the slope at each point along the way. So I want data set 1. So I clicked on this y-axis button here, and I don't want pH. I want a new column. So I'm going to add a calculated column, and I'm going to call it first derivative. And I'm going to insert the expression, and it's got this built in, so I just choose first derivative, and I apply that. Now, I don't know why this happens. I specifically told it this second graph, but it put it on the first graph. So I'm going to turn the first graph back into what it was with the pH on the y and the first derivative not visible. And then I'm going to go to the second graph and make the first derivative be the y-axis. So here's my first derivative. So I'm seeing the slope of this curve up at the top of the original curve. I'm seeing the slope at each of these given points. So I can see that the slope goes from positive to negative right in here. So that's where that curve goes from going this way to going this way. So what I really want, so I can get an x-intercept, is the second derivative. That'll make it easier to figure out exactly where that switch occurs. So I'm going to come over here and I'm going to add another column, another calculated column, and this time I'm going to call it second derivative. And when you do this part, you want to be careful. When you go to insert the expression, you hit second derivative. If you look, right, it's taking the second derivative of the first derivative, and that's not what we want. We want the second derivative of the pH. So make sure you change that to pH. Make sure it says pH. Sometimes it does it on its own, and sometimes it doesn't. So make sure it says pH. The other thing there should be your x-axis is still going to be volume if you look over here. Okay, so make sure it says pH for your y-axis. So you apply that. And of course, it put it in the weird place. So I'm going to, okay, that's okay. But I got my, okay, it just didn't make it show up. That's fine. So now I've got the second derivative on here. What I care about is this intercept of the x-axis. And so I've got a point there and I've got a point here. And I'd like to know the data in between based on all the rest of this. And the computer helps with that. It's nice. So all we got to do is put interpolate, and that's going to give us data in between points. That's what interpolation is. And so now I can drag this little guy wherever I want. There we go. And I can put it as close as I possibly can to that zero, to that x-intercept. Try and make that 0. Oh, come on. Those are 2 ones that it's going to be as close as it's going to give me, it looks like. So that one right there is going to be fine. And what matters here is my volume. That's what I care about. And it's 21.2298 is what I've got. And so I'm going to use my calculator. I'm going to do 21.2298, and I'm going to divide that by 2. Okay, so 21.2298, when I added that much volume of sodium hydroxide, that completely neutralized all of my acetic acid. So I want to know where it was when half of it was acetic acid and half was neutralized and therefore acetate, because that's going to give me, again, that concentration of conjugate base over the concentration of acid. That's going to equal 1. So the log of that will equal 0. So pH will be equal to my pKa. And then I can find Ka. So I need to find the pH at, I've just divided that by 2, 10.6149. And I probably won't be able to get exactly there, but I'll be able to get close. So this first graph became second derivative again. I'm going to make it back to the pH, get rid of the second derivative. And again, I'm looking for 10.61. Here we go again. Oh, that's pretty close. Oh, yeah, I like this one better. 10.6149. This is 10. What was the other one? 10.62 something. It's kind of hard to get it to go on it. So the pH, when I've added half the volume that it took to neutralize the acid, is 4.1264. So with a pH of 4.1264, that is also my pKa. And if that's my pKa, then I can find my Ka, right? Because the negative log of the Ka is what pKa is. So I'm going to undo that. I'm just going to put 10 raised to the negative 4.1264. And that gives me a Ka of 7.47 times 10 to the negative fifth. So I'm going to go look up acetic acid's Ka according to the internet. The value for the Ka value for acetic acid is 1.8 times 10 to the negative fifth. So we're a bit high. That's all right. We're in the right order of magnitude. 7.47 is pretty high. But versus, to the negative fourth or to the negative second, yeah, we're all right. We're on the same order of magnitude. You're going to find a pretty big percent error there. Your accuracy is not going to be great. So that's all right. The second graph should look like this. And again, we're going to need to do some manipulations. And I don't think you need to do all three graphs. I think you could just do two. So I'm going to go ahead and add a graph here. You're going to need to do this. And again, you're going to have to change this graph. We want this graph to be the second derivative. But you have to be careful. Make sure it's the second derivative of the pH. I'm going to add a calculated column. And I'm going to call it second derivative, just so I know what's what. And I'm going to insert the expression second derivative. Make sure that it says pH right here. And that should say volume. And it's done that thing again. I don't know if yours will do that. I expect it probably will. So I'm going to change this one to second derivative. And I need to select the volume. So again, I'm going to look for the x-intercept. And you do need to turn on your interpolation so that it'll give you data points in between the points we gathered. Right, that's called interpolation. When you make predictions between data points that you have, that's interpolation. When you make predictions outside of the ones you have data points of, that's called extrapolation. And you should do that with a lot less confidence. Interpolation, though, is pretty good to do. Now, on mine, because I'm using a PC version of this, I got a nice slide here, but your Chromebooks don't handle this. They can kind of do this. I just tried it with my daughter's Chromebook. They can kind of do it, but you really kind of have to just kind of click, and it's a little further, a little further. You have to kind of click through like this until you get as close as you can. And when you get as close as you can go ahead and choose that value, whatever that is. But in this case, you also have a second one. So we've got something happening here, and then we've got a second one happening here. It's a little bit flat because I've scrunched this graph into half the page, but it makes another little shape like that because we've pulled off a second proton. So in this case, we've got an acid with at least two protons that can be removed. And I don't know if you remember, but the first one usually comes off pretty quickly, and then the second one is a bit after. And there may be more on this. It looks like our pH is getting pretty high, but it's possible. So what I want you to do, you're going to find this x-intercept. You're also going to find this x-intercept. Now, when you're going to do this one, you're going to do half of the volume that you added. And that's going to give you to get to your pKa, right? Now, in this case, in the second one, you can't go to half of the volume added. You want to go from half of the volume to the previous equivalence point, because that first equivalence point means we've taken the first proton off of every molecule in there. And then the second equivalence point, now we're adding base to neutralize the second protons, the acid that is there because of the second proton. So you only want to, you're going to want to subtract, right, whatever the volume you get here minus this volume, and then half of that, and it'll get you somewhere in here. You're going to use that volume to find the pKa for the second proton. So we call this pKa1, pKa2, Ka1, Ka2. What I'm going to ask you for is Ka1 and Ka2. So you should be able to get that from these data. If you have questions, of course, make sure you shoot me an email. I can pull this up and we can walk through it together. It shouldn't be a problem. We can do it all on a Google Meet or whatever. Now, this one is an unknown acid. I'm not telling you which one it is, but you do know it has at least two protons on it. So you're going to find the Ka1, you're going to find the Ka2, and you're going to use those in the table of acids that I give you to determine which acid I used for this titration. Okay? Like I said, if you have questions, make sure you let me know. We'll be happy to help out. Monday, I will be available all day. Anytime you need to do a Google Meet, shoot me an email and I'll open up a Meet and send you a link. I'll also try and make a class one during the 2 class times. So again, if you're period 2, that is 9:15 to 9:45, and if you're period 9, it's 1:45 to 2:15. I don't care if you come to the other one; it doesn't matter. 9:15 seems pretty early nowadays, but I'll be on there. Hope to see you guys later. Good luck with this. I think you'll be fine.